Today's concept is free body diagram. It is a very important concept for physics as a whole and particularly for mechanics. I am Datta sir. I am a senior ex-professor of a number one IIT JEE Institute of India, and I am an IIT JEE faculty for many years. I have seen many students are struggling with this free body diagram in many problems. So I am making this video. In fact, I am making this type of videos on all concepts of physics for the benefit of IIT JEE students. If you are one of them, if you are benefited by this, then please like this video, share this video, and subscribe to my channel where you will get all the concepts, videos on all the concepts, and press the bell icon. Also, you may also let me know what other concepts you want in your comment box. So let me start this. This is free body diagram. Free body diagram is nothing but a diagram so that we can mention the forces acting on different direction, and then we find the force equation and we can solve the mechanics problem. But thing is, in free body diagrams, there are many small areas where students get confused. To start with, I am giving you a very preliminary example. The one block just at rest on ground. So this is, I think, the simplest example. And if we have to make the free body diagram of this, I think everybody will tell that there are two forces. One is mg downwards and one is n upwards. And if we take upward as positive and downward as negative, we will write n minus mg equal to 0 and we will write n equal to mg. I think this is a very simple example. But there are so many fallacies associated with it. Why I am talking fallacies? Because unless you clearly understand these points, you cannot go for more complex free body diagram. And there you will be definitely committing mistake. So, what is fallacy number one? See, what is mg? Mg is the force given by the earth on the block. It is acting downward. And what is n? N is the reaction force given by the earth on the block. So that means mg is attractive force by earth and n is the reaction force by earth. That means both the forces are given by the earth. Now, actually, what happens? Mg is the force given by the earth, it acts downward. So, if earth gives a force on block, then who will give the normal reaction? Block will give the normal reaction. But here you see that earth is giving normal reaction. How can one agent, that is earth, give the action and reaction both? Because mg is the force given by earth and normal reaction also is the force given by earth. We know by third Newton's law that action and reaction are equal and opposite. Here also they are equal and opposite, but how it is possible that same agent, means earth, will give the action and he will give the reaction also, which is n. How is it possible? It is not possible. So this is the fallacy number one. So what is actually happening? Happening is mg is the force given by the earth on the block. By this, the block tries to go down. And in this process, the block gives a force mg on the earth. Try to understand this sequel. Mg is the force given by the earth on the block. So, as a result, the block wants to go down, but it is getting an obstruction in the earth. So, it gives a force mg on the earth. So, whatever reaction earth is giving, that is the reaction of that mg. mg given by the block on the earth. So we have solved the first fallacy. But there is another fallacy. See, then it becomes 3 number of force all equal to mg. One is mg given by the earth, which is gravitational force. Then one is mg given by the block on the earth, which is the force given by the block on the earth due to this. And another is mg given by the earth on the block as normal reaction. So which two forces we will take out of these 3 forces? We cannot, 3 forces cannot be in equilibrium. 2 forces are downward, 1 force is upward. So these 3 forces cannot be in equilibrium, but it is in equilibrium. So we have to choose 2 forces. Which 2 forces we will take? We take forces 2 and 3 because these 2 forces are actually the force acting on the block. But force number 1 is the force given by the block on the earth. So we will not take the force given by the object, but we will take the force applied on the object. So we will take 2 and 3. These 2 are n and mg in opposite direction. So our equation is correct, but we have to understand the underlying fallacy. And if we do not understand this, we will make this mistake everywhere. This is the simplest of the problem, but there are more complex problems. So what lesson we learn from this? That any time we will take the forces which are acting on the body, not forces given by the body. So here force number 1 is given by the body, but force number 2 and 3 are forces acting on the body. So this is the lesson from these 2 fallacies. So keyword, we consider only forces acting on this system. We call it system. The body, we call it a system. So I hope you have understood. This is very, very important word, keyword. We will take only forces acting on the system. So first we will have to choose the system. Here the system is the block, and then we will have to find out what are the forces acting on the system, not by the system. So for your benefit, I have formulated a few points. This, if you follow very religiously, then you will have no problem in making free body diagram, because I have seen many students are making free body diagram, but they are not following the basic rules. So what are the basic rules? Number 1, you first identify the system. For example, here the block is the system, but there may be a group of bodies also as a system. In fact, anything under our observation is a system. It may be 1 block, it may be 2 blocks together, it may be number of blocks together, it may be anything which we are under observation with. Now, after we have identified the system, second point is define the frame of reference and define the coordinate axis. We have to define which frame of reference we are doing the free body diagram. It may be a ground frame of reference, or it may be any frame of reference, other frame of reference like a lift or anything. So we have to be very clear about this, and we have to select which are the direction in which x-axis, y-axis or z-axis are there. Then define which side is positive, which side is negative. For example, here we have taken upward as positive, downward as negative. So like this, we have to be clear about this. After doing this, we have to identify all the forces I have underlined acting on the system, not by the system. This is the most important word. And then after that, we resolve the forces along the axis, and then we will write equation for each axis considering positive and negative direction. After that, we will solve those equations and find the variables, whichever variables is asked, it may be any force or it may be acceleration. Another last point is, if the frame is non-inertial, means it may be a ground frame, it may be a frame at rest, that is inertial. It may be a frame with uniform velocity, that is also inertial. But if it is a non-inertial frame, like a lift going up with acceleration, like a lift coming down with an acceleration, in that case, we have to also write the pseudo force acting on the system. That we will follow the rules of pseudo force, we will discuss in a different place. So these are the points. You please note down, you please again and again learn, and after that, if you follow these rules and apply these rules, I think there will be no problem in making a free body diagram. In fact, the free body diagram is most vital in making any mechanics problem anywhere. So I hope you have understood this, and I hope you will learn this very carefully, and I will come to you again with another concept in my next video. So thank you very much for listening.